This is a video to demonstrate version 1 of the code, which is basically to test the actuation of the lead screw through the non-captive motor, pushing the plunger down and up without actually plunging into the vessel at this stage. So if I press this one button, you'll be able to see that the motor moves downwards. And if I press the other button, the motor will return. At this stage I have to hold the lead screw at the top to prevent it spinning in place, but when the vessel, when it's inside the vessel, it shouldn't require any holding. But yes, as you can see, it works. This is a video to demonstrate version 1.1 of the code, and this code basically is to test the movement of the motor carriage forwards and backwards on the lead screw of the stepper motor, activated by buttons. As you can see, pressing one button, the carriage successfully drives back on the lead screw. And if I press the other, it will return in the opposite direction. This video shows version 1.2 of the code, and this is testing the simultaneous rotation of the plunger component and the tray rotating motor, as these both need to move at the same time for the extrusion sequence to form the treats. So just program it. As you can see, the plunger is moving down. At the same time, the tray rotation motor is rotating. This video is to show version 1.3 of the code, so this is essentially the same as version 1.2 in that it drives both the plunger and the tray rotation motor simultaneously. However, this time that is triggered by a button press, which is important for integrating it into the interface. So when the user triggers the treat making sequence, they press a button. So this is it. As you can see, this video is to demonstrate version 1.4 of the code, and this code integrates the blending motor function. So at the beginning of the treat making process, this motor rotates rapidly when the user presses the button to drive this motor coupler, which engages with the underside of the blade cap, rotating the blade. So this sits on top of here, and then the user simply presses the button and the blade is rotated through the action of the coupler. This is a video to demonstrate versions 1.5 and 1.6 of the code, In these, I have integrated a motor carriage move function, which essentially just moves the carriage on the lead screw when the button's pressed. And I've also integrated the use of a end stop switch. So when this carriage meets this switch, basically the carriage movement will cut out, and that's because the motor is in the home position. So yeah. So when I press this switch, the carriage is moved until it's met this switch, and then it's broken the function when it's detected the switch has been pressed. It's a video to demonstrate version 1.7 of the code. In this code, I have introduced a carriage home function, and essentially what this does is every time the appliance is powered on, the motor carriage will always check whether this end stop switch is pressed, and if it isn't, that means this motor isn't home when it needs to be. So the carriage will automatically move backwards to meet the switch every time the appliance is turned on. So I'll demonstrate that now. So as you can see, the the carriage is automatically homed when power is applied to the system. For version 1.8 of the code, I have integrated a tray load function, and what this does is drives this motor carriage out to the outermost point when a button's pressed. And the idea behind this is that the user can more easily access this coupler to load the tray on top of, because when it's underneath the vessel, it's a little bit difficult to see what you're doing, and there's not that much room, so it's best for it to be out here when the user puts the tray on. So I'll show you that now. So with the carriage moved all the way out, the user can easily plop the baking tray in place. For version 1.9, I've introduced a pre-extrusion function, and the idea behind this is that the first section of movement for the plunger isn't actually part of the treat extrusion, it's just driving the plunger down to meet the surface of the treat mix. So as such, the motor just needs to move normally to begin with, just a straightforward downward plunge. Then after the point where it meets, start the extrusion sequence. So the way I've tackled this is to have a button press to start the plunging. So this is the pre-extrusion phase, and at the point where the treat mix is met, you get the more the sequence, the treat forming sequence. So this is it started now. So for versions 2.3 to 2.4, I focused on programming a different treat extrusion sequence for a different size and shape of treat. So these are bigger and longer, sort of similar to your dentist stick style treat. So yeah, the approach is much the same, starting off with a general path for the extrusion, and then using calculations to determine speeds and distances. So once again, you start loading the tray. The tray is loaded, return to its start point. So when the tray is at this point, just before extrusion, I've integrated this potentiometer, and this essentially allows you to switch between the two treat modes, so the concentric or this one, which is the lines. So to do this, you simply just rotate the potentiometer, so it's neutral positions here. If you rotate it clockwise, you get the concentric treats, and anti-clockwise you get these longer treats. So we'll do it anti-clockwise, so that's set there, and then we activate the treat making sequence by pressing this third button. So again, we start off with the pre-extrusion. So you should see the plunger come through now. So this is until the treat mix has been met, and then we can start the treat making paths, the path. So let's say here is the start of the treat mix. Okay, it's been met. So first the tray moves outwards, and then here it's starting the extrusion. So that's treat 1 formed. Treat 2, and it'll do this essentially 10 times for 10 treats. So each rotation is 36 degrees, obviously 360 over 10. For this one, I have under extruded the treat slightly, so they stop, the extrusion stops half a second before the path stops, the linear path stops for each, and this is to ensure the treats don't join up, because it's good to keep them separate for ease of use. You don't want to have to cut them up at the end, so the idea is they're kept separate. So it'll keep doing this until all 10 treats are extruded. There's also a little pause after each, and that's to allow any sort of over extrusion to come out fully extrude prior to the next treat being formed. Again, the idea is preventing them from being linked together as the tray rotates. So yeah, that's it, finished. So here you'd have a tray of linearly extruded treats ready to go in the oven. For version 2.5 of the code, I've considered what happens at the end of the treat making extrusion cycle. So as you see here, the tray is fully extended out and the plunger is gone all the way through the vessel. So the user would remove the treats and place them into the oven. But as you see, the motors aren't in their home positions, and they need to be in order for the user to remove the vessel and for the appliance to be ready for the next treat making cycle. So to home all the motors after the sequence has complete, the user presses this button on the interface. So the first thing the homing sequence does is move the plunger back to its original position. And once that's done, the carriage home function will be called to meet the tactile switch. And from here, the user can clean and remove the vessel